This video is for Homework and Mastery 1.8, an introduction to solving linear equations. In this video we are going to look at combining like terms and how we would actually solve for our x or y if we have a solution but do not know what our variable actually equals. A term is a number, a variable, or a product of a number and one or more variables. Terms are separated from other terms in an expression by a plus sign or a minus sign, such as here. Each one of these, this is a term, this is a term, the 6x, and the 7y is a term. The 8 is what we consider a constant term. It does not have a variable in it. The 6x and the 7y are variable terms. This right here is considered an expression because it does not have an equal sign. There is a difference between an expression and an equation. Expressions do not have an equal sign. An equation has an equal sign, and we will get to the equations shortly. Write a term that represents each of the following. 3 w's, or p plus p plus p plus p plus p plus p. Look at the 3 w's. Okay, I want to write a term that represents 3 w's. What I mean is, just like on the previous slide, a term being either 8, 6x, 7y, each of those are terms. I want something that represents 3 w's. 3 w's can be represented by 3 times w, or 3w. The same thing looking at the p's. P plus p plus p plus p plus p plus p. How can I write that as a single term? Right now they are each their individual terms. I want to write them as a single term. Well, let's count up. I have 1, 2, 3, 4, 5, 6 p's. So it'd be the same thing as 6p. These are ways to simplify and write things as a single term. When I talk about combining like terms are terms that have identical variable parts, meaning they each have an x, each have a p, each have a y. To combine like terms, you add or subtract the numerical coefficient, or the number, in front, and the variable part stays the same. The letter stays the same, in other words. So whenever I say combine like terms, I want to add or subtract the number part of it, and I want to leave the letter part of it only if the letter part is exactly the same. Let's look at these. Identify the like terms. 8ab plus 5a plus 3ab plus 2y. I want to identify like terms here. This term has an AB. This term has only an A. This term has an AB. And this term has a Y. The only terms that are alike, or considered like terms, is the 8AB and the 3AB. These are considered like terms. Let's look at these. Identify like terms, then combine like terms. In the previous example, it just wanted me to identify the like terms. This one, it actually wants me to combine the like terms. So I've got 4x plus 5y plus 3x. Okay. This term has an x, this term has a y, this term has an x. So which ones are my like terms? Well, the 4x and the 3y are. Since it's addition, I can commute them around and put the 4x and the 3y side by side, as I have done here. This just makes it a little bit easier to rewrite it and put them together where I can look at them. One other way to look at this, I don't tend to usually do this, some of your books do, is to pull the numbers out so that you can look at just the numbers, the 4 plus 3, and then leave the x on the outside because you know that the x is going to stay there. What is 4 plus 3? Is 7. You have 4 x's plus 3 x's gives you 7 x's. And the 5y just carries along. Admittedly, I tend to skip this step. If you need it in there, that's great. I tend to just look at this as saying, I have 4 pencils plus 3 pencils. How many pencils do I have? It's whatever you need to do at this point. Let's look at another example. Identify like terms, then combine like terms. I have 9y plus 2b plus 2y plus 4b. Okay, so I've got a 9y. Oh, I've got a 2y here. So these two would be considered like terms. Do I have any other like terms? Actually, I do. I have this group and this group. They are considered like terms. So I actually have two sets of like terms. So I'm going to rewrite it a little bit and say 9y plus 2y plus 2b plus 4b. And I'm going to combine those. Well, what is 9y plus 2y? What is 2b plus 4b? Again, you can look at it like this, pulling the y and the b out. That's up to you. What you're doing is adding the numbers, leaving the variable the same. And your answer is 11y plus 6b. Notice I did not change the y and I did not change the b at all. Okay, now then, two expressions separated by an equal sign is called an equation. Just as I said earlier, there's a difference between an expression and an equation. An expression is something without an equal sign. An equation has an equal sign. I want to translate each of these English sentences into an equation. There's a few different words that actually represent the equal sign. One of those words is obviously equals. The other word is the word is, and in this case equal to, but the little bitty two-letter words in the English language are extremely important in the math world. Is, of, things like that. Is represents the equal sign. So, 3 subtracted from what number is equal to 10? Okay, I have this subtracted from a number is equal to 10. So I'm going to put some number here. I could have used x, I could have used y, it doesn't really matter. But I have 3 subtracted from this number is equal to 10. Now I'm sure you could probably figure out what the number is, but I'm not wanting to know what the number is. I'm just wanting to translate it into an equation. Do the same thing with part B. Carrie's savings decreased by 100 equals 500. Okay, remember, we don't really know what Carrie's savings started out to be, We just know that it was decreased by $100. So we have to put a variable for carry savings. Carry savings decreased by $100 equals $500. And that's how we translate into an equation. To solve an equation, we must find a value for the variable in the equation that makes the equation a true statement. What this means is I want to be able to substitute a number in for the variable and make sure that it's a true statement. Does it actually equal the other number? Let's look at an example. Is 3 a solution to 7 minus x equal to 5? You can probably look at that and tell me what x should be. Let's go through the process of finding out what or how we would normally solve this. If I'm given a possible solution, I want to replace the x with 3. 7 minus 3. Does that equal 5? No, 7 minus 3 equals 4. This is a false statement. The reason why it's false is because 4 does not equal 5. That is why it's a false statement. Therefore, since 4 equal to 5 is not true, 3 is not a solution. Now, as you could probably look at this problem, you could tell me that x, the correct solution, is 2. Some of these you'll be able to look at immediately and know what the number is supposed to be, but I don't want you to get into the habit of just looking at it and knowing. I want you to get in the habit of looking at it and solving. The reason why is because we will get into much more difficult solutions and working them out. So let's look at this one. Solve the equation 3 plus n equals 10 and check your answer. Well, again, you can probably tell me 3 plus what number equals 10? Just using your basic knowledge, you can probably tell me the answer is 7. Okay, let's check our answer. 3 plus 7, does that equal 10? Yeah, that equals 10. Okay, that'll work. Solve the equation 6n equal to 54. So 6 times what number equals 54? Well, 6 times 9 equals 54. And check your solution. This is one that gets more difficult. I don't really know how to look at this at first. 5 plus n plus 1 equals 9? I'm not real sure what that means. So let's do some reworking a little bit. Let's first use the commutative property. Change the order inside the parentheses. Rewrite that 5 plus n as n plus 5. This is going to help me simplify it a little bit. Now then, I can use the associative property and change where the parentheses are and group the 5 and the 1 together. Now I can actually do 5 plus 1, and that'll give me 6. So what number plus 6 equals 9? Yeah, that's 3. Good. Translate, then solve. Triple what number is equal to 18? Okay, I first have to translate this. How do I translate triple what number? That would mean 3 times n is equal to 18. Well, 3 times what number is equal to 18? That's 6. That is correct. These are some basic linear equations. We will get into some others where I'm actually going to teach you how to solve, where I'm going to show you how to move things from one side to the other using the additive identities, things of that nature. That will be in Unit 2. Until then, practice on your homework, and if you need help, please let us know.